So we'll be talking about counting method, and according to this section, we're going to be talking about set, talking about probability. Now, let me just do this fast. Uncertainty is part of the process of making decision and predicting outcome. Uncertainty is addressed with the idea and method of probability theory. So we're going to treat set and numbers. Let me just introduce this topic to you. Now, I'm sure by now you should be familiar with set, and it's not supposed to be something new to you. Let me just give you some definition. When we have a set, we use sets that have been used informally in this review to mean a collection of objects. We have the objects of sets are called members, elements, stuff like that. When the set is finite, finite means that their member can be completely counted. Finite set can, like, in root tree you get to understand it. Infinite means that there is a stop. This can be counted. Infinite means you can't count it. It doesn't have a stop. And we have what we call empty set. Empty set is that it is set that does not have any value. It is void. Non-empty as set that, and okay, empty set is denoted by this symbol. Non-empty means that it has an element in it. Okay, let me just move on. As in, a list is like a finite set having member that can be listed, but with two differences. Now, let's say I have a set of numbers. Let me just continue. Element can be repeated in a list, and repetition matters. For example, a list of 1, 2, 3, 2. Let's say this is a set, and this is an element. This is another element. So in this set we have 1, 2, 3, 2, 1, 2, 3, and 2. This set we have 1, 2, 2, and 3. I'm just telling you that there can be a repetition of a particular number. That's what that's telling you. And now, in contrast to lists, when the element of set are given repetitions and not counted as additional element, and this other set of element does not matter. Now, I will allow you to read this yourself and understand it well, and I'm going to show you examples myself. For example, now this is set contain this object 6.2 minus 9 pi, stuff like that. This is set, and this one, it means that this is 5. Also, this empty set here, the method that I showed you up, empty set is always equal to 0 because it's empty. And there are some times that they use intersection when two sets have the same number or the same object. That is where they intersect. Union means the combination of two sets together. I'm still going to explain this in detail for you. This is SNT. This is symbol of intersection, and U is a symbol of union. This is U, I see here. So another thing, that if X and T has no element in common, they are called disjunctive or mutually exclusive. And the best way to represent this is but let me use my own book to explain. Let's say this is a set. This set contains this number 0, 1, 2, 3, 4, 5. Let's say this is the total set, the universal set. Every set, U here is representing the universal set. That means in this set, every number is there. You understand? And A is a subset of U. That means the number of elements that you can find is also in the total one. Of course, it can be B to the subset of U. So this is another element A, element B. Now, A union B means when you join A and B together, And when you are doing that, you don't repeat the number. Normally, you will have just arrange it from smallest to the highest. 0, 1, 2, 3, 4, 5. So that's A union B. I told you you are joining two sets together. This set and this set, that is the union. That is when U is used. So another thing you need to know is that you notice I didn't repeat any. I didn't repeat 4. There are two 4 there. This 4 and this 4 here. So I don't need to repeat it when I'm talking about union. So you just have to write it out like that. Now A intersect B. A intersect B means the number that is common between the two sets. If you look at A, set A, you have 4. Set B, you have 4. So 4 appears in the 2. That means 4 is the intersect. You understand? So that's just that. That's just that. I hope you understand. Please don't be deceived by this U. Let me just say, okay, let me change this value to Z so that you not get this confused. This can be anything. So this Z, that's all the elements. So A union B, just this U represents union. So the reason I deleted this was because so that you don't be thinking like U. Let's say this is Z. So it says Z. You understand? So it has all it's a universal set that has all the numbers. So A union B gives you this. So please just understand that. The reason I did that is because I don't want you to get confused. It can be U, it can be Z, it can be any value. Now, okay, let me go back. Now, using V diagram to actually explain this better. A, B, we're talking about set A, set B, set C. It's drawn on the diagram. This point of intersection, this place is A intersect B. Intersect, I told you. So that symbol. And A intersect C is the point. There's nothing like B intersect C. B and C did not intersect. So let me tell you what you can think about here. The region with the virtual strip represents A union C. For example, these two sides, A and B. A union B will be this, and A union C will be like this side alone. You have to remove this part for repetition. So when we are doing an example, you get to understand it. Now, B intersect C is void. It is an empty set because B and C does not intersect like I showed you the other time. They did not intersect, so that is why it's void here. But for A intersect C, there should be something because these are the intersect. A intersect B, there will be. So now, this is a formula. There's a formula I need to show you. For you to know A union B, this side and this side, you cannot. You have to do this A union B. You want to know the value that is in A and B together. You have to deduct this intersect from it to avoid repetition. And that's what the formula they have. A union B equals to A set A plus set B minus A intersect B. Same thing go for A and C. If you want to know A union C, you have to add set of A set of C minus set of A intersect C. Because if you don't remove this part from it, you are going to get repetition. So that's the formula for that. And the same thing goes for this, like I showed you now. But if you want to know B union C, since they are not intersecting, so you don't need to put this there because it will be 0 automatically. You just add A and B together and you get your answer. So that's that. You might not really have the full gist here, but let me use example to express what I'm talking about. Okay, this example I've used it before. Let's say this is another set. This set contains all the numbers A and B, and A element is this, B element is this, A union B is A and B, A intersect B is 4 because they have similar elements. I've done that. So please, um, this is something that is common. That's something you can actually learn yourself, but you have to read well. I know the explanation I gave you might not be enough for you to really have the best understanding to really understand it well, but you have to read this book very well. Okay. Multiplication principle. Now suppose we have two choices to be made sequentially and the second choice is independent of the first one. Suppose that there are k different possibilities for the first choice and m different possibilities for the second choice. The multiplication principles state that under this condition there are km different possibilities for the pairs of choice. Now, what I'm talking about, I think they're trying to talk about the sample space. For example, suppose that a meal is to be ordered from a restaurant menu and that the meal consists of one entry and one dessert. If there are 5 entries and there are 3 desserts on the menu, then there are 5 times 3 different meals. So they're talking about the total number of possibilities, total number of space. So since there are 5 of these, there are 3 of these, so you have to multiply the 2 together to get the total number of space. That's what they're talking about. So this is something, this is a background, a foundation that they are giving you for you to understand probability, because we are going to talk about probability next. You understand? So you have to understand this multiplication principle. Suppose that a computer password consists of 4 characters, so that the first character is 1 of 10 digits from 0 to 9. Okay, and each of the next 3 characters is any one of the uppercase from 26 letter of English letter, 26 letter of English. How many different password are possible? Let's listen. Suppose a computer password consists of 4 characters. That means there are 4. 1, 2, 3, 4. There are 4 characters that we can put there, but we don't know it. Now say that the first one for the first password out of the 4, we have 1, 2, 3, 4. The first one consists of 0 to 9, which is 10 digits. So that's a space like that. So we have 10 space like that. And for the remaining 3, we have 26 alphabets to form. So we are going to pick between 26 alphabets. So now for the first one, since we are picking 10 digits, that's the only thing that is available for the first password, which is so. Since we have 10 choice of number we can pick. We are going to put 10 there. For the second one, second, third, and fourth, the third is we are going to pick one of the 26 English alphabets, which means for the second one there are 26 possible words that can be picked. Third one there will be 26. Fourth one there will be 26. So all you need to do, this is a multiplication principle. That is how it works. So the first one, which is 10 digits that you can pick from, times 26 times 26 times 26, that will give you an answer. And that's what they did here. The first one, we can only pick between 0 to 9, which is 10 digits, so you put the 10 digits there. The second one, they said alphabet, in this alphabet, you put 26 there. The next one, the third one to 26, because you can only pick from the 26 alphabet. And the last, when you multiply everything together, this will be your answer. That is all about that. Now that that's the different combination of password that you can produce. Note that if repetition of letters are not allowed in the password, then the choices are not all independent, but the multiplication of the multiplication principle can still be applied. There are 10 possible choices for the first character in the password. That's what I told you. Just 10. 26 possible choices for the second. 25. Okay. This is what they're talking about. For this first one, they're talking about the fact that anyhow there can be repetition. But if they now told you that if there is no repetition of words, the first one, since you are just picking it, you have 10 space, you put it there. Second one, from the alphabet, you pick. I will continue from the next video.